Dear students, I am Dr. Rajiv Sapre. This is lecture number 15 about the chapter permutation and combination. This is part of video lecture series about HSC mathematics. We are discussing actually the part permutation of this chapter. In 1 minute I will revise the idea and whatever we have done till this moment. Permutation is an arrangement, but what we are doing is very important. Basically, whatever n objects are there, that n can be any number, any positive integer actually. So n objects are there and we have to permute them. Permute ह्याचाच अर्थ काय? We have to arrange them. Okay. Whenever you say arrangement, order has importance. That means when three objects are there, suppose A, B and C, then ABC is one arrangement, BAC is another arrangement, because there in the first arrangement, see, it was A, B and C, but in second arrangement we are saying BAC. So the order in which the elements are occurring, this is different here. So this is a different arrangement. Afterwards we will study something called combination. Their order has no importance, but here in arrangements, whenever you are saying, तुम्ही permutations म्हटलं की order has importance. And another question is whether all objects are taken together or some of those n objects are taken and they are arranged. It means when all objects n, all objects are taken together, then we should know that different arrangements that we can make are n factorial. But when out of n objects, right, out of n objects, when you are selecting r objects, that means you are talking about npr. This is the notation. npr is the notation. That means permutation of r objects taken from n. And what will be the formula for that? N factorial upon n minus r factorial. Naturally, you can see if you replace r by n, that means you are taking all the n objects from n objects. In that case, it will be n factorial upon n minus n, which is 0 factorial. 0 factorial being 1, it is n factorial only. The same rule we get. Okay, so this understanding is important. And then another issue is there. Now, in case of persons, etc., it is not possible whenever we are arranging them. But if there are numbers, right, suppose we are given, say, numbers 2, 3, 5, 6, 7, and if you want to form 3-digit numbers from that, that means you have to choose 3 numbers from them and permute them. Suppose I choose 234, then 2, 3, 4, sorry, suppose I choose 2, 3 and 4, then 234 is first possible number, then 2, 4, 3, another possible number, etc. So in that case, what I have to do is select any 3 of them and permute. So it will be what? How many are there? 5 are there. So 5p3 will be the 3-digit numbers that we can form. But when this is possible, how many these 5p3 numbers, when these are numbers possible? Whenever I am using the fact that repetition is not allowed. But here, whenever I am told that these are the numbers and form 3-digit numbers, 222 is also one of those. So every place here you can occupy by how many? 5 ways. So this can be occupied in 5 ways, this can be occupied in 5 ways, this can be occupied in 5 ways when repetition is allowed. So it will be 5 raised to 3. So whenever we solve these problems, you have to first give importance to getting this knowledge from the statement of the problem. What you want to know about whether repetition is allowed, whether repetition is not allowed, then if you have to take all the objects and permute, or if you have to take some of those objects and permute. and then there can be many restrictions on those arrangements. We will solve some problems today on that. Okay, but this is an introduction to whatever we were doing up to this moment. So we are working on फॉर्म्युला NPR आणि ह्याचा अर्थ कळला पाहिजे. NPR म्हणजे काय आहे? तर यू आर सिलेक्टिंग R ऑब्जेक्ट्स फ्रॉम N ऑब्जेक्ट्स अँड मेकिंग देअर परम्युटेशन्स. मग त्याचा तो फॉर्म्युला आहे N फॅक्टोरियल अपॉन N मायनस R फॅक्टोरियल. But instead of selecting some objects, if you are taking all the objects, then the number will be N factorial. See here, N all objects when you take N factorial. But when you select some R objects from, then this is the formula. And another issue is there, whether repetition is allowed or whether repetition is not allowed. When repetition is not allowed, this is the formula. But when repetition is allowed, you know each place of those R places can be filled in N ways. So that will be N raised to R. So all such issues are there and we have to give importance of these issues. It is not just use N factorial formula, use NPR formula. It is not so. What are the restrictions on these arrangements? Whether repetition is allowed, whether repetition is not allowed. Accordingly, answers will change. Some problems today I will discuss, and then we will go for some other part. See now here, this problem. Find the number of ways so that 8th problem I am doing now. Problem number 8. Okay. And I think this is from exercise 3. It will be here somewhere. This is exercise 3.3. Okay, so exercise 3.3 we are doing, and from that say problem number 8. What is that problem? Here arrangements with restrictions. All those things I will not do, but some hints I will give. 3.3 exercise. Out of that, problem number 8. Find a number of ways so that the letters of the word history. History means what? H, I, S, T, O, R and Y. So here no letter is repeated. So these are distinct objects. आपण काय काय ऑब्झर्वेशन्स केली पाहिजेत बघा. Distinct objects. Right, these are distinct objects. Each letter is different, so distinct. Okay, so find a number of ways so that letters of the word history can be arranged. History ची letters मला arrange करायची आहेत. Okay, and what is asked? One by one we will do. Y and T are together. See what they say is, first part in that A part, they want Y and T together. Okay, now when you want Y and T together, you know you have to consider those two letters as a one letter only. Okay, मग आता काय झालं? H, I, then what? S, then O, R and Y and T together, so that considered as a one letter only. ते आपल्याला एकत्र पाहिजेत काय. म्हणजे आता एकूण लेटर्स किती झाले? 1 2 3 4 5 6. राईट, H I S T O 1 2 3 4 5 6 7 लेटर्स आहेत. परंतु तुम्हाला Y आणि T एकत्र पाहिजेत. ज्या गोष्टी, जे ऑब्जेक्ट्स तुम्हाला एकत्र पाहिजेत, ट्रीट इट ॲज वन ऑब्जेक्ट. हा रूल कायम लक्षात घ्या. म्हणून मग काय करणार आपण? वाय टी इज वन लेटर ओनली नाव फॉर अस. मग एकूण आता डिस्टिंक्ट लेटर्स किती झाली? 1 2 3 4 5 6. ओके, सो आय कॅन, हाऊ मेनी वेज आय कॅन परम्यूट दीज 6 ऑब्जेक्ट्स? इन 6 फॅक्टोरियल वेज. दिस इज ऑब्वियस. आता हे सर्वच ऑब्जेक्ट्स घेऊन मी त्यांचं परम्युटेशन करणार. आणि आपल्याला रूल काय माहिती आहे? वेनेवर N ऑब्जेक्ट्स आर देअर अँड वेनेवर यू आर टेकिंग ऑल दोज ऑब्जेक्ट्स अँड परम्युटिंग, then there will be N factorial ways to do that. So here now, so these six objects can be permuted in 6 factorial ways. and two letters y and t can be permuted among themselves, in 2 factorial ways. Obvious, no? Y and t, this is one arrangement, t and y is another arrangement, that means 2 factorial. So by multiplication principle, I will write just MP, multiplication principle. There are how many ways? 6 factorial into 2 factorial ways. So you can calculate this number. I think it is not difficult for you. So 6 factorial is 720 into 2 factorial, that means into 2. So it will be 1440. Okay, so this is very simple issue, nothing difficult in this problem. But then you have to understand what we are doing. जेव्हा तुम्हाला असं सांगणार की हे 2 ऑब्जेक्ट्स मला कायम एकत्र पाहिजेत, त्यावेळी ते 2 ऑब्जेक्ट्स म्हणजेच एक धरायचा आपण. मग तो एक आणि हे उरलेले 5 मिळून 6 ऑब्जेक्ट झाले. मग त्यांच्या किती अरेंजमेंट्स करता येतात मला? 6 फॅक्टोरियल. दॅट इज ओके. परंतु हे दोन्ही एकत्र ठेवून सुद्धा मला ते वाय टी आणि टी वाय असे लिहिता येतील ना, त्यामुळे त्या 2 फॅक्टोरियल अरेंजमेंट्स. सो टोटल विल बी 1440. आय होप यू अंडरस्टूड दिस. ओके, this is not difficult at all. Once you get a habit of thinking in a proper line, no problem in mathematics is difficult. You have to understand in a proper way. Okay, now come to the B part of that. Y is next to t. आता त्यांचं काय म्हणणं आहे बघा, B part मध्ये y is next to t. next to t म्हणजे ते एकत्र पाहिजेतच. y is next to t. टीच्या पुढे वाय पाहिजे, हे अशी सिच्युएशन होऊ. टीच्या पुढे वाय, राईट. हे टी आहे ना, त्याच्या नेक्स्ट वाय आहे. म्हणजे आता मला, आपण इथे आत्तापर्यंत काय केलं, टी आणि वाय, आता हे एकत्रच पाहिजेत, परंतु त्याच्यामध्ये सुद्धा तुम्हाला आता टी वाय आणि वाय टी असं लिहिण्याची आता मुभा नाही. तुम्ही वाय टी लिहिलं की टी हा वायच्या पुढे आला. आपल्याला तसं नको आहे. आपल्याला काय पाहिजे, वाय इज नेक्स्ट टू टी. आय डोंट वॉन्ट टी नेक्स्ट टू वाय. सो आपण आता काय करणार, पुन्हा हे 2 ऑब्जेक्ट्स एकत्रच घेणार, कारण मला ते एकत्र पाहिजेच आहेत. फक्त त्याच्यामध्ये रेस्ट्रिक्शन काय दिली मला, वाय इज नेक्स्ट टू टी. म्हणजे काय होणार, मगाच्यासारखंच करणार आपण. एच नंतर आय, मग काय एस ओ आर आणि टी वाय, ही अशी रचना पाहिजे मला. बरं, याच्यामध्ये आपण काय म्हटलं, आता हे एकूण ऑब्जेक्ट्स किती झाले, 3 आणि 3 6. मग ह्यांच्या किती अरेंजमेंट्स करता येतील, 6 फॅक्टोरियल. मी आता ते लिहत नाही सर्व, बट देर आर 6 ऑब्जेक्ट्स, यू कॅन परम्यूट देम इन 6 फॅक्टोरियल वेज. ओके, नाव दिस वाय अँड टी जे आपण एकत्र घेतले ते मगाशी आपण असं म्हटलं की यू कॅन परम्यूट देम इन 2 फॅक्टोरियल वेज. बट नाव इट इज नॉट सो, बिकॉज ऑलवेज वी वॉन्ट वाय टू नेक्स्ट टू टी. जर इफ यू परम्यूट देम, इफ यू राईट देम एज वाय अँड टी, then it is not satisfying the given condition. So now into only 1 factorial, because that is the only arrangement which is possible. So 6 factorial, that means 720 is the answer. Okay, now coming to C, there is no restriction. Now if there is no restriction, then all the objects are there. So all of them are, say, distinct objects. हे किती objects आहेत, 1 2 3 4 5 6 7 distinct objects. Right. So if there is no restriction, then all these 7 objects can be arranged in 7 factorial ways. 7 factorial ways. Now you know 7 factorial is actually what? 6 factorial into 7. So it is 720 into 7. So it will be what? 50 40. right? This is the answer. Then begin and end with vowel, right? Begin and end with vowel. I will erase this part. Now we have discussed all this. Now I will erase this part. So now the condition given is D part मध्ये तुम्हाला काय condition दिली आहे बघा की begin and end with vowel. See, so here D part. All the arrangements that we are now making, they begin and end with vowel. Okay. Now what? So there are 7 places that we have to occupy. These are 7 letters. So 3, 4, 5, 6 and 7. How many vowels are there? This is one vowel. Vowels are vowels in this word actually. Vowels in this word are, what are those vowels? One is I, another is O. H, S, T, R and Y. They are not vowels. Vowels in the words are 2. 2 vowels are there. Now I want begin and end with vowel. So here I can put one. Here one vowel is to be must appear, and here also at the end. So now there are 2 vowels. Now, so this place, beginning place, this is suppose the place which begins and this is ends. This is not E here, huh? This is end place and this is begin. Okay, so now as I have 2 vowels with me, I can put any of those 2 here. So this place you can occupy in 2 ways. This is ways. Why 2 ways? Because I am given 2 vowels, I and O. So any of those 2 I can put here. Suppose I put one O here, then I cannot put O here. So this last place you can fill in only one way. Correct? Last place can be filled in one way. So 2 vowels are kept. Now how many objects are remaining? 5. So those objects are to be arranged here. How many ways are to do that? 5 factorial. Now there is no restriction. Okay. So first place on the left can be filled in 2 ways. In 2 ways. Here I will say O or I. O or I, correct? And then last place in only one way. Last place in only one way. Remaining 5 places can be occupied in 5 factorial ways. So total number of arrangements are 5 factorial into 2 into 1. So it will be, what is 5 factorial? It is 120 into 2. So it is 240. So like this we have to think differently in case of each arrangement. We have to take into consideration what are the restrictions given, what are the restrictions imposed on those arrangements, and accordingly you have to form the answer. So I hope you understand this. I will erase this and go for the next part of that problem. Okay, what is asked next? We will consider now. I can we can do, you can do this problem. Okay, now remaining 2 end in ST. So obvious here, now there are 7 places to be filled. 1, 2, 3, 4, 5, 6, 7. I want at the end S and T. end in st. So this is E part of that problem. So now there is no choice. You have to fill up this second last place and last place in only one way. Here it will be S only, here it will be T. End in ST. Now what about remaining 4 places? This is 1, 2, 3, 4, 5 places. Remaining 5 places you can occupy in 5 factorial ways, because now there is no restriction. Only one restriction was there, that whatever word we are going to form, it should end in ST, right? So now, so if you consider how many ways are there to fill up the places, right? So first 5 places can be filled in 5 factorial ways, and last 2 places each in one way. So total arrangements will be 5 factorial only, into 1. So that means 120. So whenever we put restrictions, see, number of arrangements will reduce, and the last part in that problem was begin with S and end with T. That is also obvious. See here, I will enlarge this. So now you want if F part, begin with S and end with T. So 1, 2, 3, 4, 5. Here it is T. This is the condition given to you. That means what? We have to think of remaining 5 places, and apart from, so in that word we have to consider now remaining objects. That means H, I, then O, R and Y, because S and T have fixed their positions. Now I have to permute these objects, okay, H, I, O, R, Y, and you have to arrange them in these 5 places. So how many arrangements of these 5 letters can be done? 5 factorial arrangements. Okay, so middle 5 places now. So we can say here, first place S, so one way only. Last place T, so one way only, no choice. Middle 5 places can be occupied in 5 factorial ways, and so total number will be 5 factorial into 1, so it is 5 factorial, that means 120. So 120 such arrangements can be made. So only one problem is discussed in this lecture in detail. And before that, I told you that whenever we are doing these problems, we have to keep watch on what is the condition, what are the conditions given, what are the restrictions while doing those arrangements, right? Whether objects are repeated or not repeated. Many times it will not be given, like it is not given here also. But from the context of the problem, you have to understand whether repetition is allowed or not allowed, like that. So I hope you understand this problem properly. We will stop here in this lecture. We will continue in the next lecture. Thank you.